All right, guys, we're going to hit Chapter 2. I do want you to go ahead and do the Chapter 1 quiz. Not going to really be any questions on Chapter 1, just a couple. For example, I really want you to know, when you finally get around to taking the exam, that Java was invented by Sun Microsystems, and that it was called Oak, and that it was created to create a portable language to use on intelligent appliances. So that's all the stuff that we talked about on the last lecture. You can review your notes over that. So Sun Microsystems called it Oak, just as a historical little commentary, and it was created so that you could write code that would run on many different platforms. And their specific goal in mind was, intelligent appliances, smart microwaves, smart ovens, TV cable boxes, and stuff like that. All right. So this is more fundamentals of programming, like if you took 1113 than anything else. But it's talking about pseudocode. What is pseudocode? Pseudocode is a way of describing the logic of a program. It describes an algorithm. What is an algorithm? An algorithm is simply a series of steps that solves a problem. And so, for example, just let me pop up Notepad here. Say we wanted to calculate, pay using time and a half algorithm, right? For overtime pay. So we would need to define our terms. We have this uses an hourly pay rate, right? We need to know that. We need to know hours worked this week. And our rule is that pay equals the hourly times the hours. And then overtime is calculated as any hours greater than 40 divided by 2. Or any hours times the hourly rate, right? Okay, that's just the background information. Let's design the algorithm. An algorithm is just a series of steps. It doesn't have to be even computer oriented or math oriented. You could have an algorithm for baking a cake. But we're going to have an algorithm. Here's what it would look like if we were doing a full-fledged pseudocode according to an earlier class, Fundamentals of Programming Logic. Now, the textbook does not show using the start and stop keyword. That's okay. What I would want to do is I would want to input the hours. We really need a larger font. Then we would want to input the rate, right? The hourly rate. Once we have both of those, we could set the total equal to the hours times the rate. Now we need to implement the overtime. If hours is greater than 40, then we have a special case, right? The bonus is equal to the hours minus 40 times the rate times 0.5, or divided by 2. Either one would work, right? Except in the examples they show using the keyword set, and at our particular book they show using these little arrows to mean equals. You'll never see those again, except in other examples of pseudocode. You're not going to type in arrow less than, right, in order to, less than dash dash in order to use an equal statement. I would really just put equals there. I'm going to go with what the book's showing. All right, and then our set total equals total plus the hours. The bonus, right? And then lastly, well, we're going to put our little endif here just to indicate the end of this block. There's no endif keyword in this language, but pseudocode is not a programming language. It's a way of describing algorithms. And then we're going to output our total, right? Maybe we want to output the bonus as well. Okay, so that's pseudocode for calculating pay based on time and a half. And yeah, there's more than one way to calculate time and a half, and I've had people argue with me. Whoopsie daisy, see, there I had my equal sign rather than the arrow that they like to show. So that's pseudocode. Here's their pseudocode. They're using the word print rather than output. I could go and make that change, right? Print total. Their example's a little bit better because they're showing what to display to the user, right? Because if the user walked up and it just had a question mark on the screen and they didn't know they were supposed to type their hours there, that would be a problem. So why don't we stick a print word in front of it, right? Print, enter hours worked this week, right? And then they could input the hours. Then we need to tell them that they're going to input their hourly rate. Print, how much do you make per hour? Question mark in question mark. Right? Just like that. I've kind of spaced it out with white space to make it easier to read. That is pseudocode for calculating time and a half. Pretty much according to how the book does it. The book doesn't show start and stop. The rest of it looks pretty good, I believe. Let's go take a look, make sure. Right, input length. So enter a length, input length. Enter a width, input width. Area, whoops, I didn't use the word set. I could go and modify my pseudocode to remove that set. Sorry, I was teaching to the book for fundamentals. There we go. Same idea, right? I really would like to use an equal sign there rather than that. But I'm going to leave it that way because this is what the book shows. So note that some of the words are a monospace font. That's when the character's width is uniform. Yeah, we know that. If we use monospace font, we're indicating that something is a variable. Well, I'm just typing it in a notepad where everything is, so I don't care about that. What is a variable? Well, this is a real vague definition. A variable is a box container that can hold a value. That's not good enough. A variable is my definition. In fact, I'm going to go ahead, it's so important, I'm going to put it in a notepad. A variable is a named location in memory that can store a value, that can store data. So a variable has 4 components, 3 of which are important to us. They have a name, right? Bonus is my variable name. Total is my variable name. They have a type, indicating what type of data they store. Do they hold a string of characters like a name? Do they hold a number? Is that number got a decimal point in it? Right? All those things are type. And then it's got an address in memory, but we don't really care about that in this particular programming language because there's no way to get a hold of that address, unlike C++ and C and some other programming languages where you can access data directly by its address rather than by its name. So I'm going to delete that. And then there we go, value. Those are the components of a variable. For example, if I want to hold somebody's age in a program, I might say int age equals 32. Now I'm writing this specifically to Java, that's why I put a semicolon at the end. The name of the variable is age. The type of the variable is int. The value of the variable is 32, right? So the name of the variable is age, the type of the variable is int, and the value is 32. Now what does int mean? Int means a whole number. It's an integer, which is a whole number. There's other data types. We're going to be using largely int and double. What is double? It's a floating point type, which means it's got a decimal point. Okay. Now there are other kinds of ints. There's a kind of an int called a long. There's other types of floating points. But for the most part, we're going to use ints and doubles. And now I may called and float when I'm talking about the code in general. I just mean that it's a floating point type. We're going to use double. All right, let's rock. Here we go. So the print statement indicates that something is going to be displayed on the screen. If you want to use a print statement to indicate more than one thing on the screen at the same time, you use a plus sign in this language. If you did Python, you used commas. In this particular language, well, in this particular language, if we wanted to do something like print, hello followed by the name, or print my name is space, well, how about age? We already have an age variable. My age is space, end quote, plus age. Right. That indicates in our pseudocode that we're printing out a value. That we're going to print this out, and then this is the variable that gets printed, And so since we had set age equal to 32 up here, there we go. It would print my age as 32. Now we're going to go back and we're going to do a little bit of this in Java pretty soon. The input statement. By the way, in Python you use the word input. In C# you use a couple of arrows like that. Excuse me, in C++ you use a couple of arrows like that. In this language you use what's known as a scanner to read it in. Well, we'll have to learn how to do that. And maybe I've already demonstrated it. I do not believe so. But in pseudocode, it's just as easy as saying input, right? Because it's not a real programming language. It's not a real programming language. Sorry for the noise outside. What does it do? It causes the algorithm to wait for the user to enter a value, right? Enter the length. We tell them that. We wait for them to type a value in, and it gets stored in that variable. When we type it into our code, it's going to look more like this. Length equals, and then we're going to have some scanner name. I'm just going to use the letters SC, ignore what that means. Next int, parentheses in parentheses, if it's an integer, or next double, if it's a double, right? And so I could say that double length equals sc.next double. That's my input statement. This is input length. That's what that means right here. A little bit more complicated syntax, but that's okay. We can do it. And of course, if it's Java, everything has to end in a semicolon. After the user enters the value gets stored in the specified variable. In this case, since it said input length, it's supposed to be stored in that variable. Here, the input statement, the next double command, waits for the user to type something in, and it stores it in that variable named length. Let's go ahead and write this program in Java. Enter a length, length, enter a width, width, calculate area, and print the area is. I think I'm going to just copy that and paste it into my Java program that I'm about to create. You don't have to do that, but I'm gonna. So I've launched Adobe NetBeans. I'm gonna do File, New Project, and since I did get Ant up and running, I hope you did too. Parts of the Oracle servers are firewalled out on campus, so if you try to install this on campus, then you run into problems. Alright, so I'm going to click Next. This is Lecture C. I'm going to click Finish. And it's going to come up with my little program, right? And here's my pseudocode. I'm going to mark off my pseudocode as comments. And this pasting business might not work at all. We'll find out. That font is way too small. I thought I fixed that last time. Maybe not. Anyways, options. Yeah, here's what I'm doing. My font is too small for you to read. I want to change that, so I'm going to go into the NetBeans options. I'm choosing Tools, Options. I'm going to click Fonts and Colors. And I want fonts to be larger than 13. How about, 18? And how about making them bold? I think that'll make them easy to read. And then apply. Okay. All right, that's much easier for y'all to read. Let me see if that pasting of the pseudocode worked. Right. But I better comment those out. There. But that's the pseudocode. Up here, I would usually put, some identifying information like the name of the class, right? My name. You put your name here, followed by CIT1613. Excuse me, 1613. Java programming. You could put the date, right? Or you could put what assignment it was. I'm just going to put that as Lecture C. Yeah, you could kind of get a hint from the file name, but just run with it, right? Always put a comment block at the top of your program with at least a little bit of information, like your name. Well, don't put my name, but put your name, right? And then we should put a description of what the program is. Now in this case, it's just a lecture over chapter 2, right? So I'm not going to put a description of what the program is, but you ought to. Now I could leave that little comment there, but I could clean up the code by deleting it. Don't care if you do, don't care if you don't. One thing NetBeans likes to do is it likes to put opening braces on the line above where it takes effect. I don't particularly like that, and I'm going to show you how to change that default behavior. But what you'll see me do is to come up to a brace like that, hit enter, and then come up to a brace like that and hit enter. Something's missing. I deleted something that I shouldn't have. I'm deleting a class statement. Hub. No, I'm not. It's right there. Something is really looking weird, like this is indented too far. I should create another project and see when I'm coming to that conclusion. Anyways, all right, so I don't have my curly brace here, I put it there. I don't have my curly brace here, I put it there. That's my personal preference. It's what the book teaches. It's not what NetBeans does by default, however it can be changed. Next lecture, I'll show you how to go into settings and change that. For now, just change it like that if you're typing along. All right, enter a length. Let's print that. Here's what a print statement looks like in Java. System, with a capital S, dot, system dot, OUT, dot, print, parentheses, quote, enter a length, colon, space, end quote, end parentheses, semicolon. And some of these things I'm not typing even though I read them out because they're already there, right? I didn't have to type out the end parentheses, it was already there. Okay, now let's let them input it. But to enter it, we have to have a scanner. The scanner is what does the input in this language. So I have to create a scanner, and I'm going to have to import a library in order to get it to work. Okay, so scanner with a capital S, scanner space SC equals scanner SC equals new NEW scanner with a capital S parentheses system with a capital S dot in parentheses and semicolon. Now, isn't it annoying we have to do all that just to read from the keyboard? Unlike Python, where we just use the input word. Yeah, but we're cool, we can do it. But it's complaining that it doesn't know what a scanner is because a scanner is in another package, it's in another class. So I'm going to click on the red arrow and do add import for java.util-scanner. You see what it did? It put it right there. It actually put it right in the middle of our comments. I don't like that one bit, so I'm going to move my comment down here. And I'm going to move this like that, right? Okay. Now that the scanner has been imported, I can actually use it. So this gives us the ability to read input. That's what that line does. The specifics of what new means and what system.in means and stuff like that, we will learn in the future. It's like learning to play soccer. There's so much you got to learn. You got to learn how to run. You have to know how to stand up, right? Because standing up would be a problem if you didn't know how to do it. You have to know how to kick the ball and bounce it off your head. And you can't just learn all those things one at a time. You kind of absorb it first by watching, soccer games and then going from there. So we're just doing some practice before we understand absolutely everything about it. You don't know what the new keyword means. Let's go for it. Let's get our input length done, right? So double space length space equals SC dot, and you notice it popped up something here trying to help me. NEXT, all lowercase, capital D, and then the word double, including that capital D. And you can see that it's highlighted right there. It's all ready for me to go. So SC.next double, capital D, with the parentheses, in parentheses, semicolon. I'm going to do the same thing now for the next part, which is enter width. So system.out.print, parentheses, quote, enter a width, colon, space, end quote, in parentheses, semicolon. Same business. I need to call the scanner with the next double call to let the user type it in. So double space width equals sc.next double with a capital D, parentheses, in parentheses, semicolon. We've done these parts right there. Now we need to do the calculation. So double area equals length times width. This word double, it just means that this this variable can hold a number with a floating point, a decimal. It's a floating point type. If I didn't want them to be able to type in a floating point, if I didn't care, if I always wanted it to be whole numbers, I might use int here instead for int, integer. All right, now we've calculated the area. We could even add a comment as to that effect. Calculate area of rectangle. And I could add a comment up here as to what we're doing, right? Calculate the, input the length and width of a rectangle. So will the language run without these comments? Yeah, of course it will. I'm just kind of describing what the program does at each particular point. All right, now that we've calculated the area of it, we can print the results. Let's do so. Except this time I'm going to use print ln, so it'll go to the next line. Unlike Python, a print statement does not automatically go to the next line when it's done. Instead, you use print ln. So system with a capital S dot, you already know this, system.out.print ln. For some reason, some folks like to type a 1 there. That's not a 1. It means print line, so that's an L. Print ln, parentheses, quote, whoopsie, I accidentally hit enter. Parentheses, quote, the area is space, end quote, plus area, in parentheses, semicolon. And again, you saw that I didn't actually have to type the in parentheses, NetBeans provided it for me. That's my program. If I scroll down, I'll see my closing brace for that method. I'm going to add a comment here that this is / this is the end of main, and that this is the end of the class. All right, I'm going to build it and hope that I got it right. So I'm going to hammer and broom, run it, enter our length, 10, enter our width, 20, and the area is 200 because that's 10 times 20. Okay, so we turn that pseudocode up here into a working program down here. What if we had to do more than one calculation in a row? What if after I calculated the area, I needed to multiply it by 2? Now this is dumb. I don't have to, right? Because it's already the area. But what if I needed to as part of the equation as some kind of further processing? I could say area equals area times 2 asterisk. That would double the amount of the area. The reason I'm pointing this out is I did not put the word double here again. You just give it a type the first time you use the variable, right? When we're creating the variable, we need to give it a data type. After that, we just use the name. So now that's an error because I tried to give it a type. So I would not do that, I would just do that. I'm gonna leave that alone though. I'm gonna delete that because we don't need that to actually be correct. I just wanted to demonstrate that to you. All right, if you have all this in, and you have your import statement, you ought to be good. Give it a run, see if it works. If not, compare your code on screen to here, see if you can get it to work. One thing you have to do is to make sure that this matches your file name exactly. When you create a project, don't put a space in the name. I should have mentioned that before. Right, back to the PowerPoint. The act of asking for a user and waiting for input is called a prompt, right? I'm prompting the user to type something. So the assignment statement, that's this thing. That's called an assignment statement right here. Why? Because it is, oh come on, it is calculating a value and it is assigning it into that. Well, I actually had more than one assignment statement here. If I go back to my code, this is calculating a value and it is assigning that result to that. same here, right? That is calculating that value, and it is assigning the result of that. That equal symbol is called the assignment operator. And here we are performing the result of this equation, this formula, this expression, and we are assigning it into that variable. So the act of assigning a variable is just putting a variable, a value into it. And the way it is expressed is variable name goes on the left, and the value or the expression goes on the right of the equal sign. So the assignment statement puts the right-hand side expression, calculates it, and stores it into the left-hand side variable. So the if statement. What if we had some logic? Remember I had an if in my payroll calculator, right? Right there. This means that this code is optional, right? It only gets performed when hours actually is greater than 40. If I work 30 hours, I'm not going to get any overtime. So that's what if means. You can have more than one form of if, right? What if that variable had more than one possible value, right? If x equals 3, then do something. Else, if x equals 4, and by the way, I'm botching this because it should be equal according to this language and a great many others, even if they don't show that in the pseudocode. Not sure they gave us an example of it. Oh, they use the word equals to get away with that. Fine. For pseudocode, I'll do that. If x equals 3, do something. Else, if x equals 4, do something else, right? And then finally, if it's neither, we do yet something else, right? So we have several different versions of the if statement. We have just plain if, we have if else, and we have if else, right? 3 different versions. In Python, you had elif, right? So this one would have been written as elif. There's no elif in this language. Everywhere in Python, you would have typed elif. You type as else if here, like that. He uses angle brackets in his PowerPoint here to indicate, just around the description of what that is. You don't actually put less than, greater than around your expressions when you're coding. We have a very specific syntax we have to follow. If we were to write this in Java, it would look something more like this. If parentheses, x equals 3, in parentheses, open curly brace, close curly brace, and I would put, do something, whatever that something function was. Else, if x equals to 4, notice again the parentheses. They weren't mandatory in Python, and in Python you put colons there, not in this language. I know some of y'all haven't taken Python, but some of you have, and that's why I'm mentioning it. And then do something else, right? And then one final else. Do something, right? Do the third thing. Okay, so this right here is equivalent to the pseudocode shown up here, right? If x equals 3, do that. Else, if x equals 4, do that. Else, do that. Same as this. We did use the curly braces. There are times when you can get away with skipping the curly braces. The only time you can skip the curly braces is if the line that's indented is only one line long. If there's more than one line there, the curly braces are not optional. They absolutely have to be there. Okay, so a condition is a question whose answer is either yes or no. That's what the book says. I say that it's an expression that evaluates to true or false. Is x equal to 3? That's true, right? If it was, right? And if it was true, it would do that. And if it's equal to 3, then we know that it's not equal to 4. So this statement would be false. And so it checks that statement, evaluates it. Is it false? It is. And so it would not do that. But We can go with it either way. Its answer is either yes or no. I like saying its answer is true or false. Either way. Okay. How the if statement works. If the condition is true, see, there they go with my word. Execute all the subordinate statements. Fancy word there. What does subordinate mean? Subordinate means all the code that is indented under that if. This is a code block consisting of one or more lines that's indented, between curly braces, and that code block is subordinate to that if statement. Up here, we had two statements that were subordinate to this if statement. And if we were going to code it in Java, it would look like this. We would need our curly braces there because that's how Java indicates subordinate code. I don't even mind putting curly braces in pseudocode, but it's not technically correct. But I like it, Maybe I'll leave that there. Not part of the standard, but maybe I'll leave it there. All right, going to scroll down now. Come back here. If the condition is false, it jumps to the line after the last subordinate statement. So if this expression was false, if this was not true, it would jump down here. Now, since I have these cute curly braces here, I'm going to delete that word indent. It's starting to look a lot like Java now, right? It's less pseudocode. That's okay, right? Where are we going with this? I'll probably ask you to write this as a program. So if this is false, it jumps to the next statement that is not subordinate. So if the hours are not greater than 40, it just runs down here and prints the total. Let's make this print statement a little bit fancier, since I'm going to ask you to do it for homework. Total space pay space this space week is $, end quote, plus, like that. That'll calculate our total pay. Or it'll display it, it'll output it. What about down here? If this is true, it runs this, and then after it runs that, it skips all the other if-else ifs and goes to the next statement underneath it, whatever it would be. But if this is false, it skips to the next non-subordinate statement, the next one that is not subordinate to that. I guess that makes it insubordinate. That sounds rude. Then it would do that. It would do that check. And if that check was false, it would jump down here, and it has no other choice here, right? There's no expression. There's no way this else could be true or false. If that one was false and that one was false, this has to be true. No way to get around it, and it would do that. But if this one was true, it would do that, and then when it hit the closing brace, it would skip down to the end of the entire structure. Because this is one programming structure. It's a decision structure. It has several different options. So the format of the if statement, I've already talked about this. If, condition, and then one or more statements, and then unindented. Else, do something else. Right. And here's an if, else, if. If this condition, do that. And remember, you would use curly braces. Else if, do that. And if neither one of these are true, else, do that. Now, it's possible that the code would work even if this was left out. What do I mean by that? If you were guaranteed that x was either equal to 3 or 4, then would you need this block down here? If x could only possibly equal 3 or 4, then no, you wouldn't need a final else. But you might put it in there anyways to print out some kind of error message, because it was supposed to either equal to 3 or 4, but it didn't. And in that case, that would be a useful thing to print out, right? Unexpected value for x. So if the grade is greater than or equal to 90, print A. Else, if the grade is greater than or equal to 80, print B. Else, if it's greater than or equal to 70, print C. Else, if grade greater than or equal to 60, print a D. Else, print F. practice problems. Write an algorithm that prints warm if the temperature is above 50, else prints cold otherwise. Warm if it's above 50, cold otherwise. All right, so if temperature is greater than 50, tab, print warm, else print cold. That's that first practice. Yeah, I'll make you do it, but I'm doing it. And this one's pretty simple, so I'm skipping that second one. The third one, print an algorithm that prints too cold if the temperature is below 50, okay if it's between 50 and 90, and too hot if it's above 90. Now there's all sorts of ways you could do that, some far more complicated than others. I'm going to show you the easy way, just with if, else, 3 conditions. We're checking to see if something, which range it is in. If it's below 50, it's too cold. Okay if it's between 50 and 90. And then hot if it's above 90. And like I said, there's more than one way to do this, but let's go with what I'm about to show you. If temperature less than 50, it's too cold. If temperature less than 50, print too cold. Else, if the temperature is less than or equal to 90, why did I put that equal then? It's kind of an interpretation, but it says between 50 and 90. And then the next one is if it's above 90. It's only too hot if it's above 90, so that means that 90 is okay. I wouldn't have counted you wrong if you hadn't put less, greater than or equal to. Let's go look. So else if temperature is less than or equal to, although you know those specifications might matter an awful lot to a customer, in which case you'd have to ask them specifically. Is it supposed to do this if it's less than, or if it's less than equal? And the term is inclusive, right? You know, this range is inclusive or this range is exclusive. If it's inclusive, it includes the number that's part of the range. Okay, anyways, so if it's not less than 50, but it is less than 90, then we're going to print it's okay. And if neither of those conditions are true, we're going to print too hot, right? Because it wasn't less than 50, it wasn't less than 90, that means it's pretty hot. It's above 91, it's above 90 degrees. If I'd worded this description, this problem myself, I probably would have made it like that, right? But I tried to follow the description exactly, and that's what I got. So that was the answer to the first one. That was the answer to the second one. And here they're going into more detail. Too cold is up to 50. Okay is between 50 and 90. And too hot is above 90. So how did they do it? And they didn't. Stinkers. Alrighty, a flowchart. A flowchart is a representation of a program's logic. It's a visual representation of an algorithm. I'm going to draw a flowchart for the pseudocode that we had for payroll. The key things to know about a flowchart is that there are different shaped symbols you're supposed to use. And this is wrong. They're showing the wrong symbols. But this is a Java textbook and not a Fundamentals of Programming Logic textbook. A square rectangle like that is a calculation. It's math. A diamond like that is a decision, like an if statement or a while statement. And they're saying that print and input go in rectangles as well. So maybe when I draw the flowchart, as much as I hate doing it, I'll go with that. I may not be able to take it. I may have to do it the correct way. Yep, you just don't do it that way. Okay, so we're going to use, guess I'll do it. Sorry guys, you're taking fundamentals. Let's run with this. Alright, I had to pause it for a while. The flowcharting website called Lucidchart was giving me real fits, which is going to be a problem for my fundamentals class that I'm teaching this semester. But let's go ahead and do what I was doing, which is I want to draw a flowchart that matches this inner hours word. how much do you pay per hour? It's going to be a little bit simplified because all I'm going to do is have the input hours, the input rate, this calculation, the if, these calculations, and the output. Well, I guess that's not that much simplified, but I'm going to skip that print statement and that much. Okay, so over here, what's the first thing we do? Input hours. What's the second thing we do? Input rate. Now the textbook wants us to use squares, rectangles, for input and output. I'm going to use the correct shape. So this is input hours, right? And then I should draw a little line to the next one. Why can't I spot it? There it is. Input hourly rate, or input rate. Let's just go with that. I'm going to squish things down, make them easier, right? More stuff fit on the screen at the same time. I'm not fixing the lines just because. All right, now we need to calculate the total. Calculations are done in square rectangles, not tilted rectangles. So we need to do the calculation, which is that the total is equal to the hours times the rate. There we go. What's the next thing we do? We have an if statement, right? We have worked our way this far. We've done all of that. Now we have the if hours greater than 40. So that shape is for decisions. If hours greater than 40, then we've got more work to do. We got to do some stuff over here. So I'm going to draw an arrow jutting off like this, just like you hit indent, right? You know, open brace, indent, whatever. And so we're going to do a math calculation. The math calculation is that bonus equals hours minus 40 in parentheses times the rate divided by 2. That's our calculation. And then we add that to our total. That's more math, so it goes in a regular rectangle. Total equals total plus bonus. And then it can rejoin the main flow of logic, right? So coming back out here, taking a look at what we're doing. See, if it was false, it just dropped straight down. Didn't do anything. But if it wasn't false, if it was true, this is kind of our end if. I'm just going to squeeze that down, change that A to say nothing. Right, but that's our end if. And then, right. There we go. So if hours was greater than 40, we had to calculate the bonus and add it to the total. If hours is not greater than 40, it just drops down and we need to output our results. So output total. And then draw a line like that. Right, now we're done. And yeah, I could clean it up a little bit. But that's our flowchart. Should have marked that unlikely to recommend at this point. But I'll see if I can get that problem fixed. Anyways, there we go. Right, we're getting our hours, we're getting our rate, we're calculating. And then the decision block, is our hours greater than 40? Yes, it is. Calculate our bonus, add that to our total. Come back out, stick that into our output our total, and then we are good to go. If I wanted to make this look even more like the pseudocode, I would have print statements above the input statements. I think I'll pause the recorder and do that. And here it is, corrected to exactly match. We just added the print statements. Print, how many hours did you work? Input hours. Print, how much do you earn per hour? Input the rate. Then calculate the total. If the hours is greater than 40, create a bonus and add that. Output the total, stop. All right, so with the pseudocode and with the flowchart and with the examples that we've already done, hopefully you could create your own program that would calculate pay based on hours and the rate. And let's get back to the Dropbox, excuse me, the PowerPoint. Draw a flowchart that does the too cold, too hot business. All right. So print enter temperature. Input the temp. Is the temp less than 50? Yeah, sure is. Print too cold. No. Go over here. Now we'll say that although it is common in some textbooks to show the yeses going down and the no's going off to the side, I prefer to do it this way, because when we write something that's inside an if statement, the subordinate code gets indented, right? So that's indented, just like our code was in our Java program. Here they're showing the subordinate code as being straight down and the non-subordinate code being indented. And so if the temperature was less than 50, it prints too cold. If the temperature was greater than 90, it prints okay. Else it prints too hot. Notice you don't see the word else. It's just kind of implied. As a matter of fact, these guys don't even put the word if inside their diamonds. I like to put the word if in those diamonds because diamonds can also represent for statements and while statements and thus, things like that. So the flow of control is the order in which a program's statements are executed. And the statements are grouped according to their flow of control. Coming down here, right? Our flow of control. Flow keeps going down here until a decision is made, and it either jumps over here and does that or it comes back. Goes straight down. Branching statements contain one or more choices. I was calling them decision statements. They're calling them branching statements. The decision block implements a branching statement. This is our branch point, right? Hours greater than 40. And loop statements cause you to jump back to a previously executed statement. We don't have any loop statements in this flowchart. If we did, we'd have some kind of line. You know, maybe instead of going there, maybe it would go back up there, right? And do that again. And we're not doing that. We don't have any loops. We don't have any while statements in our logic, so I'm leaving that alone. Loop statements jump back to a previously executed statement. Implementing a loop with flowchart. Draw a flowchart that prints happy birthday 100 times. Well, let's do that. I'm going to pick my thing over here. Just start drawing a new one. It's supposed to print happy birthday 100 times. So start. I'm just going to drag that to a new page. There we go. Don't worry, I'm not going to actually make you draw flowcharts in this class. Right. And then maybe we'll create a counter that's supposed to count, you know, from 1 to 100, something like that. So we're going to do some math. Counter equals 1. That's where we're starting. Counter equals 1. And then we're going to have an if statement. But it's not an if statement in this case, it's a while statement. So while counter is less than or equal to 100, while counter less than or equal to 100, what do we want to do? We want to print happy birthday. Print happy birthday. Then we need to add 1 to the counter, right? So the counter is 1, then it's 2, then it's 3, then it's 4. Let's do that. That's a little bit more math. So counter equals counter plus 1. Or in this language, you could just say counter plus plus, and that adds 1 to the counter. I'm going to leave it as counter equals counter plus 1 for now. And then we're going to tell it go back up and do the check again. Right? So come back and do it again. Like that. And then once it's all done with that, our program is done. So we reached a stop. Okay? So that's our loop. The book may show something different. I'm sure it does. But that's our loop. In fundamentals, I prefer to draw my loops going back like this, kind of hitting that box like that. But instead. We'll leave it like that. Let's go take a look what they did. Okay. Same thing, except they made their subordinate code go straight down rather than off to the right. Otherwise, the same exact thing. So if you're going to do a loop in pseudocode, you do while, and then the condition, and then the code is subordinate, like that. So if I was going to do that, print happy birthday 100 times. Let's do it in Java. Go back here. How about just 5 times? Really, 100 times is a little bit excessive. So let's create a counter. Int counter is equal to 1. While, parentheses, counter is less than or equal to 5, in parentheses. Next line, curly brace. Is that still large enough? I might want that to be bumped up one more font size. Can we get 20 out of here? 21. Alright. Okay, so while the counter is less than or equal to 5, let's print it out. System.out.println, parentheses, quote, happy birthday, exclamation mark, end quote, in parentheses, semicolon. And then let's add 1 to the counter. Counter, I'm going to go ahead and run to that plus plus. I want you to start seeing it. Counter plus plus means add 1 to the counter. Then we're done, right? The same thing would look good in pseudocode, but you know, we wouldn't have these words int here. I'd delete that word, and you know, and I'd probably use an arrow like they showed. Don't make these changes, right? I might not use the parentheses there because they're not necessary in pseudocode. Pseudocode doesn't necessarily use curly braces, right? Pseudocode just uses the word print with no parentheses. I'm going to be undoing all these changes real soon. Just trying to show you what it would look like in pseudocode. Maybe I'll copy and paste it into our, into our notepad file. And then I might put the word int while underneath it, even though this textbook is not showing int while statements. Right, so that's pseudocode for printing out happy birthday 5 times. Let me undo all those changes. Get back to where we were. I think that'll work. I'm going to build it, hammer and broom. Then I'm going to run it, green arrow. All right, enter length, whatever, 10, 10, and I printed out happy birthday 5 times, right? What if you had an error? What if you forgot? What if you misspelled W, with a capital D, with a capital W? I run it. It underlines that as being an error. Also, when I compiled it, in the output, it tells me exactly what it found wrong. It can be kind of hard to spot, but there it is. It is saying that it cannot find the symbol with a capital D, and it's even telling us what line number it was on. It's on line 33. So if I didn't have that cute arrow there, I could go and find line number 33. I could go and find that variable width. I would wonder why it's not defined, and eventually I would notice that it was defined with a lowercase w there. So I better define it that way as well. So the way a loop works is it's like an if statement, and if this is true, it does that. But when it's done, an if statement just drops below, keeps running on, but a loop causes it to come back up, evaluate the condition again, and if it is still true, it does that again, right? Just like an if statement branched off, did something, and then came back. Did that up here, branch off, do something, come back, keep going down. A while statement branches off, does some stuff, and then it comes back and it checks the while statement again. And if it's still true, it does that branching again. And it keeps doing this branching until the counter is no longer less than or equal to 100. So the number of times that a loop repeats can be called the number of iterations. Hey, what do you know? They did 5. And they changed it to 5 rather than 100. This thing's supposed to iterate 5 times. It's supposed to do 5 iterations. what if they left this statement off? What if we never increased count? Now it's an infinite loop. You can make a loop repeat forever. An infinite loop is one that never breaks and never leaves it. So while count is less than or equal to 5, it is? Yeah, because it's 1. It prints happy birthday. Then it comes back and we just count less than 5, less than or equal to 5? Yep, it sure is. Prints happy birthday again. Comes back up here. Is this still true? Yes, it is. Because nothing is ever changing the value of count. So it's an infinite loop. I'm going to undo that change because I don't want it to be an infinite loop. Note, it's also possible for a loop to repeat 0 times, right? What if I said count is equal to 1 and then I said go while count is greater than 5? Well, just like an if statement, if this is not true, it doesn't go in here. So count equals 1. Is count greater than 5? No, of course not, because it's equal to 1, so it doesn't do anything in there. Kind of the opposite of an infinite loop. Now, you never want infinite loops, but you know, it's quite possible that you'll want to write some code that it might not go into the while loop. Now, this is dumb because we're setting that variable, but what if that number was input by the user? Maybe it's legit to not go in there and repeat that. So tracing. Tracing is when you execute an algorithm line by line and carefully record everything that happens. I would have to write an itty-bitty little program and then bring up Excel or something like that in order to do some tracing. Maybe I can do it in Notepad. All right, so we're going to write a program where we set x equal to 3, and then we say while x is less than or equal to 5, do some stuff. What is our stuff? We say y equals y plus x. And what if we start y off at 0, right? And then we add 1 to x, x plus plus. And then finally we print done, right? Or we print the value of y once we're done. I'm kind of making this look like a combination of Java and Pseudocode. Sorry about that. Okay, so how are we going to do this? We're going to track 2 variables. We're curious about the value of x and the value of y. When that line executes, x equals 3. Then it goes to the next line. What changes? Y changes. X remains unchanged. I could, put a 3 there, or I could just leave it blank indicating that it's still 3, but y is now equal to 0. And then while x is less than or equal to 5. Is it? Yeah, 3 is less than or equal to 5, so we do this line. Y equals y plus x. Well, y equals 0, x equals 3, so y is going to change and become 3. Next line, what changes? X increased by 1. So x changes from 3 to 4. Now, since we've hit the end of the subordinate block, we come and check the condition again. X less than or equal to 5? Yeah, because it's 4. So it jumps into the subordinate block again. Y is equal to y plus x. I know this is kind of tedious. So we're adding x to the value of y. Well, y was 3. We add 4 to it, and it becomes 7. And if it was clearer to have that variable repeated every time, right? Like that, you could do that, but you don't gotta. It's a lot easier to not write the value if it's just the same value. All right, and so after we added something to y, x increases by 1, 5. Since it's the end of the loop, it comes back up and checks its condition again. Is x still less than or equal to 5? It sure is, but this is the last time it's going to happen, right? So 5 comes in here, we execute the loop. Y equals y plus x. Well, y is 7, x is 5, and so y turns into 12. Next line, x plus plus. Y changes from 5 to 6, and we print y. Nope, that's not right, So we've added 1 to x. X becomes 6. We're at the end of our loop. We come back up. Is x less than or equal to 5? No, it is not, because it is 6. So it skips the loop now and then it prints its result, right? So we trace the program. This is called tracing the program. And normally you might do it with pencil and paper, but you couldn't see pencil and paper unless I kind of got a camera and pointed it at it. Or if it's really complicated, you might use an Excel spreadsheet, but that is hand tracing a program. So pseudocode summary. Print. You use quotes to surround your strings. You use a plus sign to so-called concatenate a string to a non-string. Just kind of like I did in my pseudocode. Somewhere up here, right? This is called concatenation. It took that numeric value and it displayed the whole thing. It displayed a string followed by a number. It's concatenation. Variables, they need to be all, they need to have no spaces in them. And then they have this specific rule about how you punctuate, how you capitalize your variables. They're saying make all your variables all lowercase except occasionally with uppercase letters to represent words in the middle of them. Like this. Patient height in inches, right? These are all lowercase except there's a hump there, capital letter there, there's a hump there, and there's a hump there. And so they call that camel case because it's got humps in the middle, right? I didn't make that up, right? Or you might say weight, or mass in kilograms, right? Or you might say num students, right? That's how they want you to do it. That's great, and if I was doing professional programming, I would probably stick to that. When I'm writing code in here for students, I'm probably going to use underscores in all lowercase just to make it easier for you to read. Now that's old school, it's old fashioned, that's like 70s and 80s. And I should grow beyond that and use uppercase and lowercase like that. But when you're typing it in, if you made that a lowercase I rather than an uppercase I, or something like that, you make subtle differences like that, and then the code doesn't compile and it's a drag. So I try to write my code in a way that's easy for you to type along with me, if you're going to. So I tend to use underscores rather than uppercase letters. The book wants you to use uppercase letters. Anyways, that's what's known as camel case. Let's write the rules for variable names. Variable names can be letters and digits and underscores. You can have any combination of the above. Must not start with a digit. That's the exception. Should be meaningful. You should pick good variable names, right? Choosing T as a variable name is a lot less useful than choosing, tax rate, right? Now, when we're doing mathematical formulas and you're doing area is equal to this, that, and the other, PV equals NRT, then yeah, those formulas, when you Google them up, probably just have single letters. And when I'm doing examples in here and I'm creating a counter that, prints, the numbers 8 through 100, I might just use single letter variable names because they're easier to type. But professional programmers rarely use single letter variable names. You might want to try to avoid them. In the early parts of the programming class, I'm probably not going to, fuss too much if you do, because you're going to be watching me and I'm going to occasionally do them too. But you notice that even when I did my counter here, I didn't just make it int x equals 1 while x less than equal to 5. I could have. Instead, I chose a better variable name, because the first time you see this code, you might not know what x is, right? You certainly know what a counter is. Same business here. Enter a length. Did I have to store it in a variable called length? No, I could have stored it in a variable called L or A1 or write anything. I tried to make it as clear as possible. Also, I was following their pseudocode. Your math operators are addition, subtraction, division, multiplication, and they forgot one, which is modulus. We'll talk more about those, right? I mean, you know what addition and subtraction is and stuff like that, but we will have to talk about order of operation, which means operator precedence, which means the order in which things are done, right? Multiplication usually happens before addition, that kind of thing. You probably remember that from your math classes in junior high and high school. If, else, and then while. There's 3 ways to break out of a loop. You can have counter loops. We did a counter loop, the one that printed birthday 5 times in a row. You can do user query, which is when you ask the user if you want to continue, right? Do you want to play a game again, right? Do you wish to play again? If they typed in no, it would quit. That's a user query. And then the last one is to have a value that indicates that there's no more input. It's a special value. So for example, you might say enter test score or -1 to quit. Hopefully there's no way you can earn a -1 on the exam. If you can, then the professor's a real jerk. So, you know, they keep typing in scores. Enter a test score or -1 to quit, they type in 100. Enter a test score or -1 to quit, they type in a 50. Enter a test score or -1 to quit, they type in a 75. Enter a test score or -1 to quit, they type in -1, and it stops asking that question. That's a sentinel value. That -1 was a sentinel value. So, a user query example. Write an algorithm that converts user-entered miles to kilometer values. Keeps going as long as the user types in Y. Right? So continue is equal to Y. We do that to kind of prime the pump so that the while loop will work. While continue equals Y, we ask them to enter distance in miles, and they input it. We convert it, we print the output, and then we ask them, you want to continue? And they input continue. It comes back up because it's a while loop. Is it still equal to Y? Well, if they typed Y, it is, and so it does it all again. And ask them if they want to continue. And this time they type no, and so it doesn't loop. That's a user query. A sentinel value, like a bowling score program. It's going to keep going until the special value of -1 is entered. So enter your bowling score or -1 to quit. They type in the score. While the score is not equal to -1, now this is sneaky. That little symbol, that's not a programming symbol. There's no way you can type that. You would have to type it as not equal. That's how you say not equal. You spell it in programmerese. If you see the textbook and it shows an equal sign with a slash through it, well, they shouldn't have done it like that. They ought to do it that way. So while the score is not equal to -1, then we get to add what they typed into total score, and then we ask them, enter bowling score. Again, -1 to quit. So just like I was talking about before, right? It keeps asking them over and over and over, and they finally enter -1 to quit. And it can calculate the average. You need to avoid division by 0, but I'm going to cover that in a negative lecture in another lecture. So it could be that this particular algorithm here would crash if they entered -1 right from the beginning, right? Because if they entered -1 right from the beginning, the counter remains 0. And you'd think that 0 divided by 0 equals 0, but mathematically 0 divided by 0 is not a calculatable value. It doesn't equal 0. How many, I'm not going to even go into it, right? Pretty much any time you divide by 0, it's going to be considered an error and the program may crash, or it will produce invalid looking output. So we might really need an if statement here that said if count greater than 0, print average score. Otherwise, you know, don't do anything, because that means that they never entered any good scores. They just entered -1 right away. And a nested loop is one that's inside another loop. I'm not really going to talk much about nested loops. But here's their picture of it, right? While your number is greater than 0, do some stuff. And then while that's, we have an inner loop that's got to repeat over and over and over, and it's only when the inner loop is done that it can keep going down here and reiterate the outer loop. It's called nested, like you have, you know, an egg in a nest. This is the egg, that's the nest. Or, you know, you have nested Russian dolls where you have the little baby and it's inside the bigger wooden doll and it's inside the bigger wooden doll, whatever. We're going to talk about that a lot more if there's a quiz question over it. Last thing we're going to do today is I'm actually going to walk you through the quiz for Chapter 2. We're just going to do it together, not that quiz. Why don't we pull up the real quiz? So if you've watched the lecture, you're going to get 100 on the quiz because I'm going to do it with you. I'm not going to do this for any others, but we're going to do it this time. Okay, so a sequence of characters surrounded by quotes is called a, well, they didn't even cover that in the PowerPoint, so we better write it down here. A sequence of characters inside quotes is called a string. And we'll be talking about that a lot more, but an example, right? Your name is Slim Shady. There we go. This is a variable. This is a string. So that's a string. Which of the following is not an if statement? Well, they all have to just start with if, so we can rule that one out right away. Well, that kind of makes it the answer, right? But if these had been scrambled, we'd have to check each one. If, else if, yeah, that's good. If all by itself, yeah, that's good. If else, yeah, that's good. You couldn't start off with an else, so that's the wrong one. To surround a description of what should be placed at a particular position, what would you do? Well, this book uses angle braces to describe what goes in a particular position. Which flowchart symbol surrounds print statements and assignment statements? Well, in the rest of the books in the world, print statements go in tilted rectangles, but this book doesn't. This book uses the same shape for assignment statements and print statements, and they go in rectangles, right? Just like that. That's what they want for assignment statements and print statements. Question 5. Which one connects the rectangles? Arrows connect rectangles in the other shapes. Indicate flow of control. Which flowchart surrounds questions? Those are the diamonds. Right, up here, while the counter, well, that's a decision, it's a question. If hours is greater than 40, that's a question. So we put those in diamonds. Decisions, questions, they call them branching statements at a certain point. Statements that cause you to jump back to a previously executed statement. Those are loops. And by the way, I don't know if this thing wants you to type in something with singular or plural. I'd have to go back and look at the answers again. But I always grade these things by hand. So even if you look at the results and it shows something as being wrong and you were pretty sure it was true, if I haven't added a comment to the quiz score, then it means that it hasn't been double checked by me personally. And your grade is only finalized once it's double checked. So statements that contain one or more choices and only one of the choices is executed. That's a branch. Statements that are executed in sequence, one after the other. Well, gosh, I hope I could figure that out based on our PowerPoint. I honestly don't remember seeing that in the PowerPoint. Did I skip a page? The word follow. Sequence. There we go. Okay, here's the answer to all three of those questions, and we're going to do them a little bit more specific to try to match as well. I would have made this multiple choice, honestly. I don't want you to fill in the blank and get it wrong because you didn't put an S at the end of something. So sequential statement is one that's executed in sequence, one after the other. So statements that jump back to a previously executed statement, that is a loop statement. Do they want the S? No. Anyways, so looping. The word statements is already here, so I can leave off the fact that it's plural enough. Okay, and then statements that contain one or more choices. Those are branching statements. And then lastly, statements that are executed one after the other. Those are sequential statements. And I ought to be good to go. Click submit quiz. All right. So we're done with chapter 2 now. You're going to want to read the chapters. You're going to want to look over the PowerPoints. You're certainly going to want to do the quizzes. But the real meat of Java is in chapters 3 and so on. So that's why we got through 2 chapters in 1 week. All right, go ahead, and if you uploaded, fill out a video review form, and if you typed in any notes, you can upload those as well.